We are live. Hi everyone, welcome back to Codera. Today in this video we will discuss the LeetCode daily challenge for 28th of December. The problem name is middle of the linked list, and this problem has been previously asked in organizations like Flipkart, Amazon, Microsoft and Adobe and many others. So please consider quickly giving me a +1 in the chat if my screen is clearly visible to everyone and my voice is also perfectly audible, and then after some time I'll start with this session today. So all those who have joined this stream, please consider giving me a quick +1 in the chat and like the video as well, so that we can start with this session. This problem is very popular among companies, and usually companies like Amazon, Microsoft and Adobe, they keep on asking this question repeatedly. So we'll be discussing 3 different approaches for doing this problem, and apart from this I'll be showing you the code for all those 3 approaches. Like you can see here, I have the 3 approaches, the code with it, and you can find everything in the description. So just quickly consider giving me a +1 in the chat if everyone is able to hear me, and then we'll begin with this question. So this question is marked as easy and the name is middle of the linked list. So it says that you have been given the head of the simply linked list, right? You have been given the head of the linked list and your task is to return the middle node of the linked list, right? So if there are 2 middle nodes, then you have to return the second middle node, right? What does it mean? So all those who have joined, they can consider giving me a quick +1 in the chat so that I know that everything is working fine. Let's say I have a linked list. Hi Vanshika Kapoor. If I have a linked list that is 1, 2, 3, 4 and 5, and I have to find the middle of the linked list. So for this linked list, what will be the middle of the linked list? This will be the middle of the linked list, right? So in this I'll return the node 3, because node with the data 3, because this is my middle of the linked list, right? And let's suppose if I have another linked list, that is, let's say I am having something like 1, 2, 3, 4, then 5 and then 6. So here you have 2 middle nodes. Why? Because this here the length is odd, here the length is odd, right? So since the length is odd, so you will have 3 as the middle, but here since the length is even, so you will have 3 as well as 4 as the middle. So it is saying that if you have 2 middles, then what you do is you simply return the second number, right? So that second node, that means this 4. So here the middle of the linked list will be the node which is containing the value 4, right? Is this question clear to everyone? If the problem statement is clear to everyone, then please consider liking the video and please quickly give me a +1 in the chat so that we can begin ahead with this problem, right? So the first approach to do this problem will be very simple, right? You can also mention like what was your approach while solving this problem. So the first approach, right? The approach number 1 is, first of all, that you have the linked list, right? Let's say you have 1, 2, 3, 4 and 5. So first of all, you find the length of the linked list, right? You find the length of the linked list, and once you have the length of the linked list, let's say the length is something like len or something like that, or let's say length, right? After that, what you do is you simply do length by 2, and whatever total number of that many number of times you keep on iterating, and then you will get the answer. How? So initially you have the head pointing here, right? So let's suppose for this case 1, 2, 3, 4 and 5. So for this case, I can have a temporary variable that will be initially pointing to the head of the linked list, and this temporary variable will run until length by 2 times. Okay, so how will I do that? So let me write the code for that. Maybe you can understand it in that way a little better. What I'll be doing basically is, first of all, I'll calculate the length. How will I calculate the length? So I'll have a node star temp which will be storing the current node that I am had, or you can say instead of temp I can say current or anything like that, right? After that, what I'll be having is I'll be having int length. Int length will be storing the length of the linked list, right? So I'll say while my temp is not equal to null, so up till my temp is not null until I have reached the end of the linked list. So I'll update my temp is equal to temp next. That means I'll move to the next pointer, that is 1 to 2, then 2 to 3, 3 to 4, and 4 to 5, right? So I move to this, so that means I'll increase my length by 1, so I'll do a length plus plus, right? In this way I'll keep on increasing the length of this particular linked list. Once I am done with that, so what is the half length? So I'll update my length is equal to length by 2. That means my new length will be what? If my this length is 5, so that means if the half is what? 2. So how will I do further? So what I'll be doing is, while my temp, I'll mark my temp to, I'll again update my temp to head, that is I'll be moving to the head again. That is if I have 1 2 3 4 and 5, so I move my head again to this point, right? After that, what I do, I check, I do a half minus minus as well, right? Half minus minus, that means half minus minus means, let's say this is half, that is the I have to take the till the middle, right? So in this way, what I do temp is equal to temp next, right? Temp is equal to temp next. And in the end, what will happen? First of all, my half is currently what? Let me write, right? My half currently is 2, so I am pointing here. Now I come to this loop, I see that it is not null, temp is not null, because temp is pointing to 1, so I do a half minus minus after checking. So that means now my half will be 1, right? And after that, what will happen? I do temp is equal to temp dot next, so that means I move to this node. Now my temp is temp is at 2, now my temp is at 2, and I have my half as 1, so I come to this, I see that it can work, so now it becomes 0. Now my temp will get updated from 2 to 3, so now my temp is pointing to this 3. Now my temp is pointing to 3. Temp is not null, but my half has reached 0, right? So this condition will not work, because if it is 0, so this will break, because the condition will become false. So in that case, my temp will be pointing to what? My temp is pointing to 3, as I told you. So that is why this will be in the middle of the linked list, and in the end I'll simply return this. Similarly, you can try it out for the even case as well, right? Is the first approach clear to everyone? Is the first approach of finding the length and then finding halfway, like finding the length, then half is equal to length divided by 2, and in that way doing it, like let me show you the code part. What I'll be doing in this particular approach is, I have the linked list temp, I have the head, then I have the length. I check until my temp is not null. I keep on iterating and checking the length, updating the length. Once I'm done with that, so I check that what is the half length, what is the midway. After that, I update my temp to head again, and I iterate until I reach the middle node. Once I reach the middle node, so that my temp will be indicating the middle node, so I return the temp, right? Okay, this is what I will do. Right, now next up, there can be a second approach for doing this problem as well. The second approach will be using the concept of fast and slow pointer, right? The approach 2 for this problem is using fast and slow pointers. That is also known as, I guess, tortoise method, right? So in this way, in this method, what we'll be doing basically is, we'll be having a linked list, right? We have 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5. So I'll be having fast and slow pointers. So let me write them here, fast and slow pointers, right? So I'll be having 2 pointers, that is fast and slow. Fast will be moving by 1, slow will be moving by 2. So if my slow is currently at 1, so fast is also at 1. Now my slow moves to 2, that is it moves by 1, and fast moves to 3, right? Fast moves to 3, and now my slow moves to 3, and my fast moves to 5. So I keep on checking that if my fast is pointing to null, if my fast dot next is pointing to null, or my fast is pointing to null, or my fast dot next is pointing to null, in that case I'll break from this loop, right? So in this approach, what will be having, this will be pointing to null, right? So what is my fast is currently 3, and fast next is pointing to null, right? Fast is not null, but fast next is null, so that is why I'll not be moving further. So in this case, I will return my slow pointer, not the data of the slow pointer, but actually the slope, the node slow. So this will be returning this node, that is the middle of the linked list, right? If I try to do it for the other case, that is the case when the linked list is size even. So let's say 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5, and 5 to 6. Now if I do it this way, that is slow pointer and fast pointer. So initially I'll be having 1, and my slow will move to 2, my fast moves to 3, my slow moves to 3, my fast moves to 5. Now what will happen next? My slow moves to 4, and now my fast moves to what? My fast will move to the next, right? So in this way, what will be happening actually is, in this you can see what actually will happen. Now my fast will move to null, right? Now my fast will be pointing to this node, right? My fast will be pointing to this node, and my slow will be pointing here. Fast will become null and slow will be pointing here. So you can see that this is the middle node, right? I move my slow by 1, slow moves from 1 to 2, so fast moves from 1 to 3, right? Slow moves from 2 to 3 by 1, it moves by 1, fast moves by 2, right? Then from 5 it will move to null, right? My fast pointer, it moves to null. So from 3 to 4, slow moves to 3 to 4, right? So in the end I'll simply return slow pointer, right? Slow pointer will be indicating the position of the middle node, right? Let me show you the code part for this. Like, you will be doing this in one iteration also. This is the special part for it. Like you can see, I'll mark my slow pointer to the head and fast as head, so both will be indicating toward the to the beginning of the linked list. After that, if my fast is not null and my fast dot next is also not null, so I'll keep on I'll update my fast slow by 1 and fast by 2, that is fast is equal to fast dot next, and in the end I'll simply return the slow pointer, because slow pointer will be pointing to the middle of the linked list, right? This is the concept behind it. The basic concept is that fast moves by 2 and slow moves by 1, so that is why fast will reach the end of the linked list before. So that is why you need to check the fast is not null or fast dot next is not null. In this way you need to keep a check, right? Now, is this much part clear to everyone? If this much part is clear to everyone, then please consider giving me a quick +1 in the chat. Now there is another approach for this problem. The approach is number 3, right? Is this much part clear to everyone? Please quickly consider liking the video and also give me a +1 in the chat, so that I know that this much part is clear to everyone, right? Now there is another approach. That approach is approach 3. What is that approach? Approach is that if you see this, that is 1 is connected to 2 is connected to 3 is connected to 4 is connected to 5. If a linked list looks like this, then in that case what you can do is, let's say you mark your head here only. So you can see that always what is happening, it is very similar to the fast and slow pointer only, but what is happening, you initialize your mid to head of the linked list. Okay, so mid will be initially pointing to 1, right? And you only move your mid will be initially pointing to 1, and you mark your counter as 0. And you have the head of the linked list, that is head will be moving also, right? So head will be pointing to this node and mid will also be pointing to this node. So if my count is odd, if my count mod 2 equal 1, so if my count is odd, only then I will be doing mid is equal to mid next, right? So I'll be moving my mid only when the counter is odd. In this way I'll be doing it, right? And the rest of the condition will be same, that my head is not equal to null, right? My head is not null. Head is the original head of the linked list that has been given to me, and I have initialized my mid to that as well. And apart from this, what I'll do is, after that I'll do a counter ++, so that I can increase the count, and I'll move my head to head is equal to head next, right? In this way I'll be moving it. What does that mean? So in this way what will be happening, initially my head is 1, right? So what happens, I check my counter, so counter is currently 0, so that means my mid will not move. So my mid is 1, head is 2, right? So now head moves to 2 and my counter now becomes 1, right? My counter becomes 1. After that what happens next, I check what is my counter, so counter is 1, so it is odd. So I change my mid from 1 to 2, I move to the next, right? And my head moves from 2 to 3, right? Now my counter moves from now my counter is, instead of 1 it becomes 2. Okay, please explain me again. Which explanation do you want? Okay, now my count moves to 2. Now I come again, I see that count is 2, so it is not odd, so I increase my counter, so the counter becomes 3, and my head of the linked list is now 4. So now my counter is 3, I come again, I see that the head is not null because the head is pointing to 4. So my counter mod 2 is what? My counter mod 2 is odd, so that means it is 3, so it is odd. So I increase my mid from 2 to 3, and now my head moves from, now my counter increases to 4 and my head moves from 4 to 5, right? After that I come again, so I see 4 mod 2 because 4 is even, so it will not come inside this loop. So my mid is still 3 and my head moves from 5 to 6, not 5 to 6, 5 because 6 is not there, so my head moves from 6 to null, right? It moves to null, so it reaches the end of the linked list, right? The traversal of the linked list will be done, and my count moves where my count becomes 5. But now I check my head, so my head is pointing to null, so that is why I'll not move further, and I simply return my mid. What is my mid indicating? My mid, notice that my mid is currently indicating to 3, so you can see in this way it is working, right? Now let me just clear some space and let me show you how it will work in the case when the linked list is of length even, right? This will also work when the linked list is even. Abhishek, you can let me know which part is not clear to you, like was the fast and slow pointer part not clear to you? I'll repeat it after I have shown all of you the solution for this case, right? So now what I do is let's make some space again, and let's try and iterate again. So what I'll be doing, I have the mid, I have the head, and now I have 6 as well, right? So the linked list is now this is how my linked list looks like, right? So what you are doing here is, in this case, is my head is pointing to initially 1. My head is 1 initially. Let me write it clearly. So head initially will be 1, my head will be 1, and my mid also will be 1 because it will be pointing to the head. My counter currently is 0, so I check is my counter odd? No, it's not, so I update my counter by 1 here, and my head moves to 2, right? After that I check is my counter odd? Yeah, counter is 1, so it is odd, so that means I increase my mid from 1 to 2. My counter increases to 2 and my head will move to 3, right? After that I check is my counter odd? No, it's not, so that means I'll not be changing my mid, but my head moves to 4 and my count moves to 3, right? Now my counter is 3, I check again, so my counter is odd, so that means my mid will move from 1 to 3, right? And in this way what will happen next up, my counter becomes 4 and my head will become 5, right? I check my counter, so since it is even, so since my counter is even, so I'll not update my mid, and now my counter becomes 5 and my head becomes 6, right? Right after this what will happen, since my counter is 5, so counter is 5, so I come into this iteration, so that means 5 means the counter is odd, that is 5 mod 2 will be equal to 1, so in that case I'll be moving my mid from 3 to 4, so I move my mid is equal to mid dot next, right? Similarly next up what will happen, my count moves to 6 and my head moves to null because 6 is pointing to the null, that means the end of the linked list. So since my head after that is pointing to null, so that means I have to simply return my mid. Why? Because I have iterated through the complete linked list, and if I'll return the mid, so mid is currently pointing to 4, that is this, which is the middle of the linked list for even cases, right? Is this much part clear to everyone? Just quickly let me know in the chat. Please consider giving me a quick +1 in the chat if this much part is clear to everyone. If it's not clear, then you can let me know. I'm waiting for your comments, so just let me know whatever is the case in this one. Is it clear to everyone? If this is clear to everyone, please give me a +1 in the chat. If something is not clear, let me know in the chat. I'm looking into your doubts. I'll answer your doubts. Like someone mentioned that maybe the 2-pointer approach is not clear. So 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5. So basically in that approach what I'll be doing is I'll be having a slow pointer. Slow will be pointing to 1, hi Ashoka, and my fast will also be pointing to 1, right? So my fast moves by 2 and slow moves by 1, so slow is equal to slow dot fast, right? Slow dot next, right? Slow is equal to slow dot next, and fast is equal to fast dot next, right? Fast is equal to fast dot next. So if my slow moves to 2, then my fast will move to 3. If my slow moves to 3, so my fast moves to 5. Now I see I have to check a condition that if my fast always moves to fast dot next, but if my fast dot next is itself null, then it should not move further, right? So in this case I will simply return my slow, that means I'll simply return 3, and that is the middle node in this case, right? Let me show you again for this case. Explain really well. Thanks a lot, Ashoka. Thanks for your compliment. Hopefully I'll try to, you can find all the 3 codes to the implementations that I have talked about in the description of this video, and you will be finding everything, every code for there, right? And you can submit those codes, right? If I have 1 2 3 4 5 6, and if I have my fast pointer and my slow pointer, right? So my slow will be initially 1, my fast will be 1, my slow moves to 2, my fast moves to 3, my slow moves to 3, my fast moves to 5 because 4 and 5, right? My slow moves to 4 and my fast moves to null, right? My fast moves to null. So since my fast will be null, so in that case I'll terminate and I'll simply return my slow. the concept is that fast is moving by 2, and my slow is moving by 1 only, right? So my slow now returns only 1, or returns 4, that is the middle of the linked list. For this, whenever the linked list is of even size, so the second middle node will be the middle node, right? So in this case I have to return 4, that is what my slow function is returning. Notice that every approach is the same. First approach, let me briefly summarize. So the approach 1 for this question is find the length. You first of all find the length, right? You find the length and then check, you do the half, right? Half is equal to length divided by 2, and you iterate from the head until that you reach until your half becomes 0, right? And in this way your temporary variable or your current variable will be pointing to the mid, right? The approach number 2 that we had discussed was using fast and slow pointers, right? Fast and slow pointer, that is also known as tortoise method, right? Apart from this, there can be the third approach that we have also discussed. This is a unique approach. The third approach is nothing but using count and increment and changing or you can say updating mid when only when counter is odd, right? Only when counter is odd, right? Because you are that is also similar to the fast and slow pointer approach, but here you are using the concept of count, and count is even or odd, right? And this particular problem, if I'll tell you this particular problem, that is find the middle of the linked list, that is the middle of linked list. If you are preparing for some companies, like if these companies are your dream companies, that is Amazon, if Amazon is your dream company, or Flipkart, or Microsoft, Adobe, right? All these companies keep asking these questions. Specifically Amazon and Microsoft are the ones who asks a lot of questions on linked list and binary trees and things like that. So if you are preparing for that, so all the three approaches that I have explained, all these are accepted on LeetCode. I have checked all these solutions. I have myself prepared them, so you can be assured you can learn all these three approaches and try them out yourself. And in case if someone has doubts, so they can mention that in the comments. Thanks a lot everyone for watching this video, and do subscribe the channel if you are watching the recording, because we always we are daily bringing the LeetCode daily challenge, so you can be consistent with us. We are trying to solve it live, so that everyone is able to do it, and we are trying to make it like something like 100 days of code or consistent coding, right? Thanks a lot everyone for watching this video, and I'll see you soon.